Good day to all of you. Today's topic is equations of motion and its subtopic is rectangular coordinates. So the question is the 40 kilogram crate shown below rests on a horizontal surface with coefficient of kinetic friction 0.3. If the crate is subjected to a 400 Newton towing force as shown, determine the velocity of the crate in 3 seconds. The force is 30 degrees above this horizontal line and coefficient of kinetic friction 0.3. It is 40 kg and from rest. Okay, so we have to determine velocity after 3 seconds. The formula that we're going to apply to calculate this velocity is V equals to U plus product of AT, that is final velocity equals to initial velocity plus product of acceleration and time. This initial velocity equals to 0 meter per second because it is from rest, and the time given is 3 seconds, and acceleration unknown. That means we have to find out this acceleration before determine this velocity. So this F equal to ma is equation of motion of Newton, and this F is actual force acting on the crate, and m is mass and a is acceleration. Forward force minus friction between crane and the surface. The surface here is where the crate rests on. Okay, so forward force minus this friction force equals to mass times acceleration. Okay, so it applies to this formula. So we have to identify forward force and also the friction between the crate and the surface. So force Px is acting forward and Py is acting upward. So this is the fraction of the force. So forward force here 400 times cosine of 30 degree, and so first we identify this Px. So here that is the vector of this both force. Okay, so this forward force is 400 cosine of 30 degree is 346.41 Newton. Okay, and we come back to this Py next. So coefficient of kinetic friction is 0.3. So what we're going to find out here is this forward force is Px, and next we're going to find out what is this friction force. So for the friction force, we need to identify the normal force of the crate. Normal force of the crate is acting downward. So actually there are two forces acting on this crate in terms of downward and upward. These are the actual force acting on this crate. upward force Px, weight of the crate mg times gravity, Py acting upward, and this is friction. And the normal force of this crate, weight minus Py, because it is not in the same direction of this weight. Okay, friction force between the crate and the surface is equal to coefficient of friction times normal force of the crate. So now the normal force of the crate equals to weight of the crate, that is m times gravity acceleration minus the upward force, that is Py, because the weight of the crate acting downward and this Py acting upward. So this one almost 392.4, that is the 40 times 9.81, and this one is equals to 200. So still the force acting downward almost 192.4 Newton. So the actual normal force is 192.4 Newton, and it is acting downward. So applies to this formula. Okay, applies back to this formula. 0.3 times 192.4 Newton. So the friction between the crane with the surface, between the crane and the surface, is 57.72 Newton. So we come back to the original formula, that is Px minus friction, that is 3.4 minus 57.72, that is 346.41 minus 57.72 equals to 288.69 Newton. Okay, now this is the actual force acting on the crate. So applies back to the F equal to ma, that is equals to 40 times a here is acceleration, and so we can easily identify this acceleration from here solving this problem, 7.22 meter per second square, and applies back to the formula here, that is v equal to u plus product of acceleration and time. So the v here, initial velocity is 0, acceleration is 7.22, and the time given was 3 seconds. So the velocity is 21.65 meter per second. Thank you.